What time have we got? Let's see. 12:59. Excellent. 1 minute, 1 minute early. Let's spin this around. There we go. Good afternoon, Internet. I did what you're never supposed to do as a comedian slash teacher slash, I don't know, person toiling in obscurity. Yeah, I threw away a perfectly good bit. All right. I threw away a perfectly good bit because now I'm starting at one. I don't get to ramble on for a solid like minute and a half about how it's 11:59 and it's morning, or it's 12 and it's 12:01 and it's afternoon, or it's 12 exactly and it's neither. Right? It's exactly noon. It's not morning and it's not afternoon because after is right in there. It's built in. Although I suppose this is a good teachable moment, right? Because now I can talk about, well, is it exactly noon? Of course it's not, right? For how long is it exactly noon? Well, that depends on what sort of measurement we're using, right? Like, is it 1 second afternoon? Does that count as afternoon already? Is it 1 nanosecond afternoon? Does that count, right? So it's another reason why mode is useless. It's a callback to yesterday. It's also the precision of our measurements, the precision of the tool that we're using to measure the amount of time, right? So that is not only a call back, it's a call forward. That'll be, we'll get to that when we talk about significant figures, which I will definitely do if anybody is doing a physics course, especially. I do love physics. I will answer every physics question on stream that I can. Um, I will do science questions as well. Just science doesn't always lend itself to sort of being done on stream, but physics, for example, certainly does. Right. So now over on the side here, you notice we've got my little buddies again. We have Flurry and Smokey here hanging out, keeping me company. Right, another picture from up at the cabin, as most of my best ones are. The best pictures are always from the cabin. Okay, so like I says, we are starting. I'm going to start now in a second here. I'm going to launch into my material for the day. I'm going to start with area of irregular shapes, like it says there. So Renetta, that one is going to be for you. Hope you can come by and check out the stream live. If you can't, then I'm going to well, you know how it works. It sends you out a link to the video and all that, right? So drop in chat if you're here, and I'll get to it. Otherwise, yeah, gonna ramble a little bit more before I get started. I'm going to be keeping an eye out today, sort of to my left here. I live in a basement apartment, and sort of to get to my apartment, you got to walk down along the side of my house. I got sort of a blackout curtain put there now, although, I mean, it's a real scuffed sort of blackout curtain. Look at that. It's actually a painting drop cloth that I had lying around in a closet, right? But I mean, everything's a little bit scuffed these days. It's very much we're making do, right? Is what I'm saying. But anyway, I can still kind of tell down across there when someone walks down, and I've got a delivery order for groceries that I made from Coleman's, which is a very nice local grocery chain here on the island of Newfoundland. Um, yeah, it's uh, they're offering free delivery. Takes them a few days to get it out, but it's an amazing service. It's really great for getting your groceries in while staying, social isolation. Um, yeah, I'm super grateful that they're doing that. If you're in the St. John's area, you can get that as well. Um, I know you can get it in Mount Pearl for sure, and you can get it anywhere in St. John's proper. I don't know about the outlying communities. I don't know about CBS or like Torbay or wherever. Um, but yeah, you can definitely get it within the city. And there are three Coleman's locations. I think only Mount Pearl and Newfoundland Drive are currently delivering, although the Merry Meeting one might as well. Oh, okay, Renetta. Good afternoon. Glad to have you with me. Yeah, and I'll jump in to answering those area of irregular shapes questions there now. But it's a good thing. It's a good thing Coleman's is on the way. I hope they get here today because you see this? Look, that's the last one. That's the last one, chat. Earl Grey tea is almost extinct. It's tough. I mean, it's hard out here, right? I got to go to drinking like orange pico. I don't know. I don't know. Actually, I don't even have any orange pico. I've got um, I've got green tea and like this old like rooibos thing that I've had like one bag left of for years because it's just kind of like I don't know. It's not quite what I expect when I'm having a tea. It's all right. Anyway, let's flick on over here. I am going to oh yeah, I'll just don't need to comment more about the lovely pictures of fluffy dogs. Let's slide on in then. So I'm going to start with actually let me get my sheet and keep it here alongside me so I can see what topics I'm doing when. There we go. There we go. Perfect. Perfect. So first up, I'm going to do the area of compound shapes or of irregular shapes, right? And normally, Renetta, you'll know that from the Prism Math Blue and Purple, I don't actually have digital copies, but I've gone and taken pictures of the sheets that you are dealing with. So let me. So this is the first page that you asked about. Now, not super duper clear there. So let's go over to the document display over here. Okay, it's a little bit clearer there now. Um, so here what we're going to be doing is finding the area of each figure, right? I took this from the answer key, which is why there's the blacked out parts on there. You know, these ones over here, right? But to find the area of a shape like this, we're just going to have to split it into smaller shapes that we can find the area of. Now, I'm not going to go ahead and do these ones exactly, partly because this is a really important activity. You will see this topic again later, and it's a really good example of the kind of outside the box thinking that you'll have to do for some of the geometry questions. But I have got a worksheet. Let's see, which one's my worksheet? There we go. Perfect. So full screen that one. There we go. Wonderful. So I've got this worksheet that I'm going to go over, and yeah, you're going to see how to do this one based on how to do the page that you're talking about in your book based on this worksheet here. Okay. Oh, well, now you see the solutions. Not a big deal. Not a big deal for that one because this is just one that I made up. Okay, so let's start in. This is going to be Prism Math Blue. Page 183. Oh, let me zoom my guy out a little. Repositioner. Good. There we go. Wonderful. So Prism Math Blue, page 183, starting with question 1 here. Now, we'll see that the shape is like an L shape, right? So there's two different ways that we can do these sort of questions, and I'm going to show with a few different examples, right? So first up, I'm going to draw out the shape like so. You do need to avoid measuring the shapes, right? Because the thing is, oftentimes, well, it's less important here because obviously this one's not 18 centimeters long at the bottom. But even like for diagrams that show angles, you can't just measure the angle with a protractor and use that because sometimes the teachers are sneaky, right? We're devious ones we are. We'll pull a sneaky on you and make it so that the angles on the diagram are not at all the same as the angles that we're saying are there. Sort of. So you always take the number that's written there and then use computation to figure it out. You don't just measure. And it's the same for these guys too, right? If this says 9 and this says 9, but this one's actually like a little bit longer than that, it doesn't mean anything. Okay, so there's two different ways that we can do these questions. The first and perhaps most straightforward is to break it into several sections that we know to find the area of, right? So I don't know how to find the area of sort of an L-shaped Tetris block, but I do know how to find the area of rectangles. So I'm going to take it. I'll use the dotted line to show that I am splitting it apart. Use this dotted line and I'm going to split it apart right here, right, into two different rectangles. Now what do we have? Well, now this rectangle up here is 9 centimeters by 9 centimeters, right? Which means this part in here is going to be 81 centimeters squared because it's those two multiplied together, right? This one down here across the bottom is 18, and this one up along this side is 9. So that is going to be 162 centimeters squared, right? So your total area, or your area overall, then, is after you've found the area of both sections that you split it into, we're going to go ahead and add these guys. So that's going to be, let's see, 243 centimeters squared. So there we go. For one like that, we just had to split it into different shapes. I'm going to bounce all over the place on this page. I'm not just going to stick with the ones in order because I want to be showing you some very specific things. Okay, so say for question 4. Question 4 is a good one. We've got a shape then that's actually no, instead of 4 first, I will do 4. I will do 4. I'm going to do 7 first, actually. Because 7, I know 7 looks more complicated than the other ones, but it's actually fairly easy, and it's a good example of sort of the second way that we can solve these equations, right? 1, like I did in question 1. Oh, I've got some poppy seeds hanging out from my lunch. I had a poppy seed bagel and a bowl of chili. So here's my attempt at drawing that one. So we've got 22 meters across here. We've got 28 meters across here. And then from here down, or sort of this line, we're told that that one is 20 meters. Now, like I was saying, there are 2 ways to do any of these guys, right? One way is going to be to split it and then add them together. But what I'm going to do for this one is I'm going to sort of imagine that it was a full shape. So I'm going to imagine that instead of having a triangle down here and being cut off, I'm going to imagine that this was a full rectangle. So full rectangle. If that triangle sort of shape that's omitted wasn't there, what's it going to be? Well, it's going to be 28 by 22. And that one I am not going to do in my head. That one's going to be 28 by 22. It's going to be 616. Or it's not centimeters, it's just meters. Meters squared. Don't mind me. That's an M. That doesn't look much like an M. It looks like a squiggle. All right. M squared. There we go. But now, we don't have this full shape, do we? What we have is this shape subtract this triangle in here. So now what I'm going to do is I'm going to find the area of this triangle, and I'm going to subtract it from this amount, right? So now we know that the area of a triangle is a half times the base times the height, which means here it's going to be a half. The base is across the bottom, so that's going to be 22, the same as this one up here. And the height of the triangle is 20. Right? So a half times 22 times 20 is going to be the same as 11 times 20, which is going to be 220 meters squared. So then our area for our regular shape is going to be 616 subtract 220, right? Which is going to give us 396 meters squared. Right? Because what I've done is I found the full shape, got it here, and then I subtracted this other bit that was taken away from it. So then, like I said, I will do question 4. Question 4 is a good example of one that can be done either of these 2 methods. Right? The way that we did 1 was split it apart. The way that we did 7 was treat it as a full shape and subtract. 4, we can go ahead and do sort of either of these 2 ways. Number 4 then, yes. So we have 18 cm here across the bottom. We have 10 cm over here on the side. and we have 8 centimeters. Well, where does the 8 centimeters go from? It goes from here all the way over to here. And they even draw a nice dotted line just to make it clear that this 8 cm goes from that side on over to that side, like so. Okay, so now there's two ways that we can solve this one. We could, let me do it in two different colors over here. So what we could do, actually first I'll do one in blue, is we could split it down here like so, right? If we split it down there that way, we know that this is going to be 10 centimeters here, right? We're told that, but what's this distance here? Because now we've got a rectangle and we've got a triangle. Well, this distance here is of course going to be this distance, subtract this one. So now we know that this is at 10 meters as well, or 10 centimeters. 10 times 10 is going to be 100 square centimeters. Easy, right? Here now, we've got a triangle. So over here, we've got the area of a triangle, which is a half times the base. Well, we know the base is going to be 8, because it's 8 across here, which means it's going to be 8 across here as well. And then the height is going to be this dimension over here. So that's a half times 8 times 10, which is a half of 80, which is 40 centimeters squared. Right? So then our total area is going to be 100 plus 40, which is of course going to be 140 centimeters squared. Easy. Another way we could do this one, and I'll do this in red, another way we could do this one is to say that, well, let's treat it as if this was a full shape. Right? Let's treat it as if it was a full shape, and there's this extra sort of triangle added on, right? This red guy over here. So what would this be? Well, the full rectangle would be 10 times 18, which is 180 centimeters squared. And now the red triangle would be a half times base times height, which again is going to be a half. Our base is going to be 8, because it's still 8 across this way. You could think of this as an upside down triangle, right? Where I know it's on the top in the way we've drawn it, but this is still the base, right? Because you can reorient the triangle as you want, as long as the two measurements that you're picking are perpendicular from each other, then you can just orient the triangle however you like. It's going to be 8 this way and 10 this way. So a half times 8 times 10, which is again going to be 40. So your area is then going to be 180 subtract 40, which is 140 centimeters squared. So either way that you do that, you're going to end up with the same answer. So now I want to, let's see, I'll show you two more wrinkles, two more wrinkly ones. Let's do questions 6 and question 8. Those ones are fairly dense. They've got a bunch of stuff going on. Actually, I'll tell you what, I'll do question 3 as well. I'll do 3, 6, and 8. Because those have each got some significant stuff. So then, question 3, and anyone who's watching, Renetta or anybody else, if you want any more comments on stuff, or you want me to do some examples that I'm not doing, yeah, just drop a message in chat or send me an email. So we've got a racetrack looking shape here, which is a curve on one side, straight across, then a curve on the other side. Excuse me. So then we've got a dotted line there and a dotted line there, right? And we're told that it's 8 between here and here. And we're also told that it is 2 between here and here. So this line is 2 cm. That's a little bit small. So maybe I'll 2 cm, and I'll point the arrow into that. Okay? So, oh no, look at that. My internet seems to have recovered. It seems to be doing great today, actually. Good stuff. Good stuff. I thought it was just buffering for a second, but I think I'm, yeah, we're back to smooth Smooth and smirmy. That's another reference to the same strong bad email. Anyway, so in the center here now we've got a rectangle. It's 8 across the bottom, but what is it going to be over here? What's this distance going to be across the side? How can we figure that out? Well, we're told that the distance from the middle of the semicircle out to the side is 2 centimeters, right? So the radius of this semicircle that's over here, and the radius of this semicircle that's over here is 2. But 2 is the distance from the middle to one of the ends. So that means the distance from one of the end to the other end is going to be the diameter. And if r equals 2, therefore we know that diameter equals 4, because diameter equals 2 radius. Right? So if radius is 2, diameter is 4. So the rectangle, we'll call this area of rectangle, is going to be 8 times 4, which is just going to be 32. 32 centimeters squared. Okay? Now I know that I don't think you have any circle ones right now, but these are totally fair game that you will see in the future, so that's why I'm covering these here. These are 2 semicircles. But 2 semicircles, semi means half, 2 semicircles go together to make a full circle, right? So even though it looks weird, all it is just the same old normal circle, just split up into 2 places. So the area of a circle is going to be pi times radius squared. So here it's going to be pi times 2 squared, because it's the radius, which is going to be 4 pi, which is going to be exactly 12, right? Because pi is exactly 3. What? No. 12.6. It's another Simpsons joke. On a test, do not write down that pi is exactly 3, please. It's a very startling thing to hear. So all I'm going to do now is go together and add these guys. So it's going to be area total is going to be equal to the area of the rectangle plus the area of the circle. So that is going to equal 32 plus 12.6, and that is going to be 44.6 centimeters squared, just like that. Okay. So these are some decent examples for that Prism Math Blue page. I'm going to do, like I said, I'm going to do 2 more on here. Then I'm going to look at least 1 or 2 of the long answer questions, or the worded problems that are on 184. That's page 183. Okay, so now I'm going to do, I'll do question 8 first, because question 8 is actually a bit easier than question 6. This math aids that I use it from, you'll see this down below me, down in my FAQ down below. It mentions that this is a really good site for practice. It is. It's excellent. As long as you know the topic that you want, you can probably find a sheet on math aids that will just make up some drills for you. And it comes with answer keys as well, which is really useful. So in question 8 now, we have rectangle with another rectangle in the center of it. And there is a question on your page 183 almost exactly like this one, right? And it tells us now that these are actually, they're not just rectangles, they're squares. We're told this is 6 meters and this is 6 meters, this is 3 meters, and this is 3 meters. But the section that we're trying to find the area of is not the full guy. The section is just this sort of bit out here. Right? So that is the area that we're trying to find. So how are we going to do that? Well, we could split it into 4 different rectangles. We totally could, right? We could split it, say, down along here if we wanted to, and then down along here. And then we could find out this rectangle, this rectangle, this rectangle, and this rectangle, and go add them together. You're totally capable of doing that. But say if you had circles instead, that would be impossible to do, basically. Well, not impossible, but impossible to do with the tools that you have been given in this course. But what you can do instead is you can just subtract. So I'm going to find the area of the full circle, or the full rectangle. So we'll call this area of LS. So I'll call this large square. Area of the large square is going to be 6 times 6, which is 36 meters squared. Area of the small square is going to be 3 times 3, which is 9 meters squared, right? So the area total here is going to be 36 subtract 9. So the area total is going to be 27 meters squared. That's it. That's all you got to do for that guy, right? 27 meters squared right there. You can see it, right? See the answer key. I'll leave this key up for a minute. Right, because this is a, like I said, this is a practice sheet. This one's not even in your book, but you can get dozens and dozens of ones just like that at mathaids.com. I am not sponsored by mathaids.com, for the record. I kind of sponsor them though with the amount of traffic that I give them just from creating my own worksheets. Anyway, now I'm going to do question 6. Question 6 is a nice, interesting one because it actually brings in semicircles again. You will see semicircles eventually, and semispheres and all that kind of nonsense, right? But the thing about when we did the semicircles in question 3, well, we treated them just like circles, right? No, I didn't break out my compass and draw that one exactly. Apologies. But we are told this is 10.5 centimeters across the bottom. And then here, like say this was the center of the circle, the distance from here to here, excuse me, is 7 cm, right? So here now we've got a rectangle. It's going to be 10.5 across the bottom. Well, what's it going to be over here? Well, I know that from the middle of the circle to the end is 7. So from one end of the circle to the other through the middle is going to be twice that, or it's going to be 14, right? Because our r is equal to 7. Diameter then is equal to 2 times 7. So the diameter is equal to 14. So the area of the rectangle, right? So by the area of the rectangle, I mean imagine that you had a dotted line sort of going down through here, right? This would now make a whole rectangle. So the area of that rectangle, if it existed, would be 10.5 times 14, which is going to be 147. 10 14s and then a half of 14. That's going to be cm squared. Now we've got, excuse me, I'm a bit phlegmy today. Now we've got to figure out over here what this semicircle is going to be. Well, we know that the area of a circle is going to be pi r squared. So what's the area of a semicircle? Well, it's going to be a half pi r squared, right? Because like that only makes sense. Because this is half of a circle. Half of the circle is going to have half the area that a full circle would have. Right? So the area of the semicircle is going to be that. So here it's going to be a half times pi times 7 squared. It's going to be 49. Half of 49 is 24.5 pi. 24 and a half pi, so I'm going to eat half of one of the pies. 24.5 pi. You know, I haven't had a Fabulous Foods turkey pie in like 4 or 5 months. Now I'm craving one. Now I'm craving one that I'm talking about half a pie. You get like half a turkey pie with a big old plate of chips. Oh yeah, it's good. Best chips, fries. Best fries in the city. Fabulous Foods, I think. I'll fight you. I'll fight any of these Ziggy's supporters. I don't know. Ziggy's is okay, but like the packages they put it in, it's got this like wax paper on the inside. It comes out very soggy, right? Like Fabulous Foods at least wraps it in brown paper. Like not wax coated or anything. So, you know, it's actually crisp when you get it. Anyway, quite opinionated about my deep fried potatoes, obviously. 76.97. I worked in a few different restaurants around town when I was going to Munn. So yeah, I do have some strong opinions on some of the takeout fare here in the city. But yeah, there's some really underrated gyms, let me tell you. 147 minus, I'm just going to say minus 77, we're going to get to 70. So our area total, I'm just going to round that to 77. It's going to be 147 cm minus 77 cm, which is going to be 70 cm squared. There we go. Excellent. Okay. So that's page 183. That's all the ones that I'm going to do as examples for that page. Hopefully that was a little bit illuminating. So let me switch over now my file back to this Prism Math page. I'm going to look at these ones. Okay. So I'm going to do a few of these guys, not all of it. It must be why you always talk about food. Yes. Yeah, I do. I do talk about food all the time. I mean, you know, it's what keeps me going, both metaphorically and literally. So this is going to be 184 over here. Let's see, which of these questions am I going to do? Renetta, if you want to, if you're in chat, you want to drop in some messages about any specific ones you want me to cover, do let me know. Otherwise, I'm just going to pick some. Just do number two. Number two is good. So, Ashley has a garden shaped as shown below. What is the area of the garden? Well, I mean, this is hardly a word problem, is it? I mean, they could just have given you this compound shape of triangle plus rectangle, right? The worded part didn't really add much to this question, although a fancy spelling of Ashley, it did add that. So that's cool, I guess. So I'm going to go ahead and draw out this diagram here. And let's see, I'll indicate that it's a right angle. You really should. You really should indicate that it's a right angle there because that lets us know that this is the height and this is the base, right? Because the height and the base of triangles need to be at right angles to each other, which means they need to be perpendicular to each other. Right, so then this is 3 meters, this is 5 meters, and this is 8 meters. Okay? It would be okay if you were on the right page. Well, I mean, I think this is what you asked for, right? This was 184. Pretty sure this is page 184. Let me know if I'm doing the wrong one, if I'm not doing the one that you asked. But yeah, this is the Prism Math compound area stuff. It's a, oh, yes, okay, thanks. It is a, yeah, this is the one that I get questions on a lot. Partly because it's so different than the stuff that you've seen so far, but you do see this topic again. Yeah, it does come up in some of the later courses as well. So I'm going to break this one down now. First, the area of the rectangle. So the rectangle is this part down here below. That one's just going to be 8 times 5. So the area of the rectangle is going to be 40 meters squared. Right? And then for our triangle, area of the triangle is going to be half times the base of the triangle. Now we know the base of the triangle is going to be 8 because it's the distance across here. 8, and the height of the triangle is going to be this 3, right? A half of 8 is 4, 4 times 3 is 12. So this is going to be 12 meters squared. So our area total, I'll call it area total, is going to equal just 40 plus 12. The area total is going to be 52 square meters. There you go. Okay, maybe I'll do 5. Maybe I'll do 5 and 6. Yeah, let's get a few other ones done here. So number 6, yeah, number 6 is a bit of a twisty one, isn't it? So I'll do 5 and 6, I think, and then that'll probably be enough for this page. So number 5, the treatles have a lot that is 55 by 120. All right, so our lot is going to equal 55 by 120. So the lot is going to be, I could probably do that one in my head, but 6,600. Why bother? Because it was, 5 times 120 kind of twice, right? So yeah, 6,600. That makes sense. And that is meters squared, right? Their house is 32 by 38, so the house is going to equal 32 by 38, which is going to be 32 by 38, going to be 1216. And then their garage, la-di-da, garage, I call it a car hole. So the garage, or the car hole, is 20 by 24, which is just going to be by 24. So speaking of things that I should be doing in my head, 480 meters squared. So now the question just asks you to find out how much of their lot is vacant. Well, for this one, we don't even really need to do a diagram, do we? Because it's, you know, all the situation that we need to understand is right there in the question. So they're going to have 6,600 minus 1216 and also minus 480. So this is the area equals that. So it's going to equal 6,600 minus 1216 minus 480, going to be 4904 meters squared. That's all there is to that guy. And now then, yeah, we want to do question 6 as well. Question six is a bit of a tricky guy. So I'm going to go ahead and I'm going to draw out sort of a quick version of the diagram that's there for question 6. Might not have all the same proportions, but of course that doesn't matter. What matters is the numbers that we write on it, not what the shape looks like. Okay, so there's roughly our shape. We've got 12 meters there. Let's see, 16 here, 12 meters here, 8 meters down that way, 12 meters that way, and then 32 meters this way. Okay, that's what we've been given. Now, how in the world are we going to find the shape, right? So what we could do what I'm going to draw out in blue here, right? What some people do when they see a question like this is they immediately think, all right, chop this guy into threes, find the area of this, the area of this, and the area of this, right? We totally can do that. That's fine. We just have to be really careful about the measurements that we have for each of these sections. This one over here is going to be 12 times 16, 192 meters squared. This one over here is going to be 12 across the top times 12 this way, which is 144 meters squared. But now how are we going to find the area of this guy down here? Well, we've got to find the measures of the sides that we don't know, right? So we don't know the distance across here, but we do know that this side over here is 12, and we know that this side here is 8. So if this is 12 and this is 8, this has got to be 4 meters, right? And by the same token, if we know this is 16 and this is 12, and this whole thing is 42, or 32, sorry, 32 minus 16 is 16, 16 minus 12 is 4. So we know this is also going to be 4. So this one here is going to be 4 by 4, which is 16 meters squared. All right, so if we did it in blue by adding, I'll call this the adding method, it's going to be 192 plus 144 plus 16, which is going to equal 352. 352 meters squared. Right? So that's one way we can go about doing this one. But I'm also going to show a subtracting. Right? Because what I'm going to do is I'm going to say, well, imagine that this shape here was actually filled in. Right? So imagine instead that we went and got some concrete or some whatever, modeling clay, I don't know, and sort of spackled in this gap. Right? Oh, it's square meters of carpeting. All right, well, say they removed that wall or whatever it was, the support that was there, and we then needed to carpet this small little bit as well. What's this bit going to be? Well, the area of the gap or the part that's left out, we just found that this bottom is 4. We know that this is 8, so it's going to be 4 times 8, which is going to be 32 meters squared, right? And then we can say the area of full rectangle. So imagining like the thing was one big shape, right, without any parts left out, it's going to be 12 by 32, right? And 12 times 32 should equal 384. I think that's right. Yes, 384 meters squared. So then we know that our area, the area that we're looking for, is going to be the full 384 subtract the 32, which is the gap. And that's going to again get us to 352 meters squared. So either of those two methods will work fine, right? You definitely don't need to do both of them like I've done here, but just pick one. Oftentimes subtraction will be easier. Personally, I think subtraction here is easier just because you're doing a little less work. A little less work means fewer opportunities to make a small mistake, right? So I think that is a good way of doing those. So Renetta, I hope that answered your questions then on area of irregular shapes. I'll send you, yeah, after we're done here, I'll send you some resources based on what I've done today that you can take a look at as well. Some notes and things, right? So that is, let's see, stream starting soon. Here's my my little sheet with the arrow to my fuzzy buddies. They're not there right now. Area of irregular shapes, Donarino. Welcome. Brittany, if you're in chat, speak up sometime and I'll go ahead and do the distributive property questions because I know you had those to ask about. If you don't want me to get onto those right now, or sorry, if you're not there, I am going to carry on with some percent calculations. I'll give you a minute or two to respond while I bring up the percent calculation stuff. So like I said, if you sound off in chat, I'll know you're there, and I'll know it's time to go do the distributive property questions. Let me see here. Which page am I looking at now? There we go. That's the one. Oh, sorry for the view that I'm showing you, Twitch chat. That's not the it's not the most elegant of views. There we go. This is looking good. So now I'm going to zoom in a bit here. So this one now is for Carly. Now Carly, I don't think is watching the stream live, but hopefully she is able to see it afterwards. So hello, future Carly. This is past Peter here, hoping that social distancing is finding you well, and I hope that this will be useful as you're doing your math, right? Because this is the unit that you're currently working on. Your previous unit was done very well. Yeah, and so I'd like to get you started on the second one, get you a bit of a leg up so that you'll understand how to do some of these questions as well. This is the pre-test that I'm working on here. This is not a page that you are responsible for, but it is one that covers sort of all the different types of questions in this unit. So hopefully some of the ones that I do now will be very good examples for you. So this is Prism Math Blue, Chapter 6. 6 pre-test. Okay. So there are several different ways to do these questions. Now you see that the answer is already there for us for question 1A. But, you know, it's one thing to have the answer, it's another thing to know how to get it, right? So here, I'm going to show you the ways that we're going to get it. So what you'll have written down is blank is, so you'll see blank is 40% of 80. Right? Now what you need to know how to do is to take this math writing and turn it into, take this English writing and turn it into math writing, turn it into symbols. Right? That's how we're going to be able to solve these ones. So blank, or an unknown, how do we write that in math symbols? Well, that is, of course, an x, an unknown. What's is in math? Right, so the unknown is x. Is of course, an equal sign. Right, 40 is 40. I mean, that's not difficult. But what's percent? Percent literally means out of 100, right? Because like I keep mentioning, right? Per means out of, and cent means 100. Right? There's 100 cents in a dollar. Cent is 100 in French. Right? Lots of different ways to know that one. Of, now what's of? Of is the operation multiply. Okay? It's not going to be true in literally every question that you see. Just because the word of is written in a word problem doesn't necessarily mean you're going to have to multiply. But when it's, say, 40% of something, it means 40% times that thing. And of course, 80 is just 80. So what we have now is x equals 40 over 100 times 80. Right? We can, of course, reduce 40 over 100 down to make our working a little bit easier. You don't necessarily have to. I will. I'll say this is x equals 2 over 5 times 80, right? So then I'm going to cancel a little bit. So 5 goes into 80. That'll be 16 times. That'll be a 1, and that'll be a 16. So then it's just going to be x equals 32. There we go. So now we know that we can go and put that back in there and say that 32 is 40% of 80. Just like it's written out up there. Right? So the important part, like I'm saying, is being able to take these and turn them into the way it's meant to be written. I'm going to do a few of each type here, just so you get a good feeling for the types of math that you're going to be doing. So this next one, yeah, this one's got, yeah, maybe I'll do 3a instead. 3a, something, so blank, is 3 and 1 over 2% of 120. So there's a few things you're going to need to be able to translate here, basically. We know that blank means x, is an equal sign. 3 and 1 over 2. Well, what is that, 3 and 1 over 2? Well, I'll tell you how to do it. If you're ever unsure, right, you're going to go to your calculator, which you can use on every course here on out. You've already gotten past the one course where you can't use a calculator. So for every course going forward, you'll be able to use a calculator. So we're just going to do 1 over 2. If we're unsure, we're just going to put it in like that and find that's 0.5, right? So this is the fraction. The fraction at the end is the same as 0.5. So now we're just going to add the whole number to it. So we know that 3 and 1 over 2 is the same as 3.5. So x is 3.5% of 120. Okay? Now, I'll write this in a bit of a different way. Here, I'm just going to combine it together, 3.15 times 120 over 100. This is sort of the way you're going to see these guys written later on down the road as courses keep going. You'll see a dot used for multiplication instead of an x. For our purposes now, that's kind of just to keep it separate from the variable x. So you don't need to worry about like dot product versus cross product or anything like that. If you happen to Google that, well, we won't touch those topics. But for us, the dot just means multiply. Dot in the center, not dot on the bottom. That's a decimal. Anyway, so this 120 and this 100, I can cancel those ones, right? I could call that 12 over 10, right? Because I can cancel out the 0 out of both. But then 12 over 10 can also reduce down to 6 over 5. So now on the top, we have 3.5 times 6 divided by 5. So 3.5 times 6 is going to be 21. So we're going to have 21 over 5. Now you notice over here on the answer, they did 4 and 1 over 5. Well, that's a good way of doing it, right? Because that's going to get you, that's using the skills that you've gotten from a previous course that you were doing, where we can take a improper fraction like this and turn it into a mixed number. Well, in order to do that, we know we divide 21 by 5, right? If we divide 21 by 5, like so, we see it's 4. It's 4.2. So personally, I'm okay if you just write down 4.2. But to refresh your memory on how we do these ones, basically what we're going to do is divide, and then we take just the whole number, so just the one that's to the left of the decimal, and we write that one down here. Then as the big number. Then what we're going to do is we take away 4 5s from here. Well, what's 4 times 5? 4 times 5 is 20. So I'm going to take this 20 away from what we've got up here. So we've got 4 and 1 over 5. Right? We can write it like that, or we can write it as 4.2. Personally, I'm totally okay with this. For the vast majority of courses you do, I'm going to prefer the answer to be sort of like this, a 4.2. And you see, even in the very next question over here, they actually, in number 4, they went ahead and wrote it as, it's a good euphemism, isn't it? Yeah, writ it. He writ that one, as 59.2. So let me scroll down now and get to the next type of question, because you notice these first four are all the same form. These next 4 are all the same form, and the ones that follow that are the same form as well. So I'm now going to carry on then. We'll do question, let's see, I'm going to do question 5a. So what I'll end up doing here is 2 examples of each type of question. Right, so here we have 35 is blank percent of 140. So again, we have to be able to turn that into math symbols, right? Turn the words into math. Now, just like I keep saying, learning the basics behind all of this is going to allow you to tackle questions that you didn't necessarily know how to do per se. Like if you forget how to do a question like this on a test because you've got like 3 different types to remember, it can be a lot to remember sometimes when you've got like you're just a brand new 3 different formats, this one, and the one that we're going to see in a bit. But if you remember the basics of how we convert this into symbols, and then you remember the sort of algebra fundamentals, you'll be able to solve it on the fly, even if you don't remember exactly what you have to do in those questions. So 35 is, blank goes in as x, percent goes in as out of 100, of goes in as multiply, and 140 hangs out as still 140. So now what I'm going to go through is I'm going to reduce these down as much as I can. 35 is equal to, well, 140 over 100 is the same as 14 over 10, which is the same as 7 over 5. So that's going to be 7 over 5 times x, there like that. Now, how do we get rid of this 7 over 5 that's here by the x? Well, I have talked to you a lot before about cross-multiplying. So cross-multiplying is really what we're doing. Right? There's loads and loads of different ways to write this out. If you asked like 5 different tutors, you'd get probably 4 different answers. Because we could also multiply by the reciprocal, but I like to keep hammering home the same sort of ideas that we've seen before. Remember, cross multiply is x over y equals a over b becomes xb equals ya. Right? Just to keep hammering home the same points that we've been talking about throughout this whole thing. Right? And we know that any whole number, well, any whole number is the same as itself over 1. There's an over 1 there, we just don't write it in. Right? So all that's going to happen is, this is a long-winded way of saying that this 5 is going to come up here and multiply by this 35. So we're going to end up with 35 times 5 equals 7x. Well, 7x times 1, but of course times 1 doesn't do anything. Right? So then 35 times 5 is going to be 150 plus 25 is 175. And that's going to equal 7 x's, right? Now, we've got to get rid of this one that's here by the x. In order to get rid of this thing by the x, we had to do the opposite, right? This is multiplied, so we've got to divide. 175 over 7 is equal to x. And you will see over here on the side that that answer is going to be 25 equals x. So there we go. 35 is a quarter, or 25%, of 140. Right? So this is just showing us how we cross multiply here. Right? Another way you could have done this was to say, well, since this is 7 over 5, since it's 35 equals 7 over 5x, to get rid of the 7 over 5, we had to multiply by the opposite, which is 5 over 7. So we could call this 35 times 5 over 7 equals, we're going to multiply this side by 5 over 7 as well, like so, 7 over 5x. I'm sort of cramming it in there. Then over here, this is going to cancel with this is going to cancel with this, and we're going to be left with still our 175 over 7 equals x, so our 25 is equal to x. That's just sort of another way to do those do the working there. But as you see, it works out to be exactly the same. So I would like to introduce it as cross multiplying. I think that makes the most sense. Okay, so now I want to do let's do question 8. Question 8 is a really good one. Question 8 over here in red. So 8 is 0.5 is blank percent of 1.6, right? So what's that going to be? Well, it's going to be 0.5 is x out of 100 times 1.6, like so. Okay? So it's actually going to be 0.5 equals 1.6x over 100. So I'm going to go ahead now and I'm going to do my cross multiply. I'm going to end up with 0.5 times 100 equals 1.6x. So 50 equals 1.6x, like so. Then we're going to have to divide to get this 1.6 out of here. 50 divided by 1.6 equals x. And 50 divided by 1.6, as we see over here, is 31.25 equals x. We see that up in the corner. Right, went through that one a little bit faster, but you'll see that that is very similar to what we were just doing, right? Now there's one other type of these questions that I'm going to get to here now. It's going to be, let's see, let's do questions 9 and, I'll do question 9 and 11, because 11's a bit of a wrinkle. Excuse me, bit of a wrinkle to question 11. So now I'm going to go ahead and do question 9. Question 9 is a different way of phrasing this one. Oh, what have I got? Have I got a message there? Nope. Again, I'm being a bit leery about my messages today. I'm trying to keep an eye out for them because, like I said, I've got that Coleman's order coming. Again, right? Anyone in the St. John's area need some food delivered to you? Mine's supposed to be coming today. It takes a few days for them to get it out. But yeah, it's a really great service. Super happy that they're doing that. So number 9, 21 is, oh, sorry, I'll write it out in words. 21 is 30% of blank. So what that tells us now is it's going to be 21 is 30 out of 100 times x. Right? But what happens here, comes exactly like this step over here. Once we do this, it's going to be, these two are going to be exactly the same. Really, I mean, not exactly, but it's how it's going to be written out is going to be the same. 21 is going to equal 3 over 10, 3x over 10. Now I can do my cross multiply. And move a little bit quicker here. 210 equals 3x. So then 210 over 3 equals x, or 70 equals x. Just there like that. All right, so that's all we got to do for that guy. It's, yeah, it seems more complicated at first, but actually once you get into it, it's actually very manageable and very in line with all the stuff that you've seen so far. So now question 11, I'm going to do this one. This will be the last one that I'll do on this topic. So question 11 then. 25 is 25% of 100. 25 is 25% of blank, right? We know that it's 100. We're already told that because this is the answer key. You wouldn't be told that if you were actually doing the question. So we have 25 is 25 out of 100 of some number times x. So what we have now is 25 is equal to 25 over 100. I can call that 1 over 4, right? Or 25 is equal just to x over 4. 1x over 4. So now I'm going to cross multiply. And I get 25 times 4 equals x, or 100 equals x. Now, 100 is, of course, a special case whenever we are dealing with percentages, right? Because 100 is a full one, right? So 25 is 25% of 100. Of course it is, because 25 is 25%, right? It just makes sense. So that one was a fairly easy one. You probably could have got that one without doing any working at all. But that just shows you the way that we're going to break those ones down. So, Carly, I hope that was helpful for you, right? Let's see. I will be moving on there now to, let's see, did I just, oh no, no, my stream is still fine. Stream's still fine, looking good. Looking good, okay. Right, so that was, yeah, those questions that I wanted to get to for Carly. So I'm gonna switch on there now. Again, Brittany, I know you wanted to be there live, I think, while I went over them. So if you're there in chat, drop me a message and I will start in on the distributive property questions. Right. If you don't show up and drop a message in, I will get to it before the end of the stream. Just I'm leaving yours because I know that you wanted to be there live in case you had any questions to ask. So I'm going to move on to a bit on outliers and central tendency. Okay, so this one is going to be useful for Esther. I don't think Esther is watching today. I don't know if she's maybe working on her other subjects. Oh, well, there's an adorable picture. But I am going to go on now to, I'll take a look at the textbook, just a touch, just briefly. Okay, so, like it says here, table below shows the NHL point leaders for 2 seasons, right? And this might actually be accurate. Like, look at those Gretzky scores, right? Like, the man was just, he's called the great one for a reason, right? Like, look how far in the lead he was, like, even above Mario Lemieux. Like, Mario Lemieux was the second highest point scorer, and Gretzky just, like, totally dominates him on points. A lot of Gretzky's points were assists, too, which just shows how good of a player he was, right? Because he wasn't just the star forward that made all the goals or something. He brought the team up as well, right? Yeah, very skilled team player. A team player is what we're about in Canada, right? You know, we're all in it together. I'm pulling for you because we're all in this together. Keep your stick on the ice. Anyway, I'm not signing off yet. Don't need to go stealing lines from the immortal Steve Smith. Or Red Green is his character name. People think Rick Green was Red Green, but he wasn't. Rick Green was Bill in Adventures with Bill. Steve Smith was Red Green. And Patrick McKenna, of course, is Harold. Yeah. The old yeah, that's another bit of Canadiana there. That's real good stuff. Like Handyman's Corner. Oh, look at this. Look at this, right? I've actually got duct tape there. Of course I'm talking about Red Green. My desk has I've denotated where my notes need to go using duct tape. Right? If women don't find you handsome, they should at least find you handy. Okay, so determine the range, mode, median, and mean for the data for each season. Okay, so let's see. This is page, what page is this? 82. This is math 3102A, unit 2. This is going to be page 82. Okay, so then question A is going to be determine the range, mode, median, and mean for the data for each of the seasons. Okay, so here now, I'm going to do the range for season 1. So we'll call this the 1985 to 1986 season over here. So the range, well, the range is always the largest minus the smallest, right? I'm going to do this one over here. I'll do the range for this guy as well. Right, so we see that the largest point scored was 215. Smallest point scored was 116. We're going to subtract those guys. It's going to be 99. Ha! 99 points. Right, we see the 99 there at the top of the screen. Gretzky's number, of course. I believe that was right because Gordie Howe's number was 9, so Gretzky wanted to be 99. I don't know if that's true or not, or if that's just a legend that he picked 99 because Gordie Howe was 9. I don't know. We got any hockey nerds in chat? You can look that one up. Email that one to me. We get a confirmation. Okay, so the range of the second one then is just going to be 104 minus 85. See that the range is 19. Boy, that's a bit different. That's a it's a touch different there. So the mode. What's the mode in the first one? Well, there's no mode. Oh, that was supposed to be in black, wasn't it? My goodness. Twitch chat. Gotta be paying attention to that, huh? I really gotta be getting my colors right. So then the mode for the second one is also no mode. Right? Another example of why mode is not a super great measure to use very often. Right? Let's see. Median. Well, the median is just going to be the middle number in order, right? So how many do we have here? We have 7. So it's going to be the fourth one. So the median of the first one is going to be 131 points, right? And the mode for the median rather, for the second one is going to be 94. 94 points. There we go. Right? Good stuff. And then the mean. Well, the mean, we got a bit more work. So I'm going to write it out here. So I'll show you. This is sort of a notation that we can use to describe what the mean is. This is a Greek letter sigma. You don't need to write it out like this. You'll never need to. But I'm just showing you sigma is a math symbol that means sum of. So it means sum of. S-U-M, not S-O-M-E. So the sum of n divided by n, sort of. So it's all the points added together divided by the number of entries that we have, right? So the sum of all of them for the first one, let me just write that out. Actually, I'll put E down on the table. 8, 131, 123, 122, 116. Right? So it's 986 is our total, divide by 7, and we get 141. So the mean is 141. Now the mean over here for the other one, mean for this guy, once we clear this one, 657 divided by 9. I'll just write that out. 657 divided by 9 is going to equal 73. So we can see here. Oh, no, I must have. Oh, Lord, not divide by. Don't mind me. Don't mind me. 657. Actually, hold on. So it's going to be 657 divided by 7, because that's actually the number that was there. 657 divided by 7 equals 94. Hey, it's exactly the same. This is a good teachable moment, again, right? Because I'm a really big proponent of reminding people that you should be trying to get a bit of knowledge and a bit of advantage wherever you can in these sort of activities and on these tests and things. So here, I got 73 first, but I knew that was wrong. I knew it was wrong immediately, right? I knew it was wrong because if I look back over to here, oh, there's my cursor. I look back over to here, 73 is lower than any of these results. And we know the average or the mean can't be lower than all the results. It has to be somewhere around the middle, right? So we knew that 73 was obviously right out. Which data value appears to be an outlier in one of the two seasons? Explain what might have caused the outlier. All right. So then B, well, we can see this by looking at this data over here. And this is super important, and this is one of the reasons I wanted to cover this topic today, or wanted to cover the topic in general. It's because, look here, the mean that we found for A was 141 points. The median that we found for A is 131 points, right? Okay. There we back over here. So we've got 141. Now, 141 is the mean, which means supposedly the middle number, right? But if we look over here, we see that, wait, 141 right there, that's the second number. That's the exact number that Mario Lemieux scored in that season. The second highest point scorer. Are they the average? Are they the average of the highest seven? No, of course not, right? The second highest person we shouldn't be considering that the average. The reason it's considered the average here, or the reason it's the mean, it's one of the averages, um, is because of the outlier. And the outlier, as we can see in the first set, is the great one. It is Wayne Gretzky, coming in at 215 points. To the next person's 141, right? So the outlier is, oh, I always spell Gretzky wrong. I always put an S in there. Okay, so the outlier is Gretzky at 215. We know that. What might have caused the outlier? Because he's right. So that's a good reason. It's a good reason. Good reason for why. I used to watch Pro Stars as a kid too, right? So this is probably why I think Wayne Gretzky is so awesome. You ever see this show? You ever see this show in like the early '90s? This cartoon Pro Stars. It was weird. It had, what was it? Wayne Gretzky, Michael Jordan, and Bo Jackson. Bo Jackson, who was apparently like a Hall of Famer in both football and baseball. So it had like a hockey star, a basketball star, and a football star. Just and they were, I don't know, I can't even remember. I can't remember what they were doing. Saving the world from evil villains, probably. I don't know. That was a while back. Okay, so outlier is Gretzky because he's awesome. Yes, and he was on a cartoon show. It's the point of my story. Remove the highest and lowest value for each season and find the trimmed mean. All right. So now a trimmed mean is super important, and that was one of the topics I wanted to get onto today. So Esther, if you're watching this live, hello. If you're not watching it live, future Esther, I hope you're watching this at some point because yeah, you do need to know this topic. Okay, so I'm going to go ahead and calculate that one. So the trimmed mean, that's going to be part D over here, for 1985 to 1986. The trimmed mean is going to be 141 plus 138 plus 131 plus 123 plus 122, and that's all going to be over 5. It's over 5 now because we only have 5 entries. So the trimmed mean then is going to be 141 plus 138 plus 131 plus 123 plus 122, 655 over 5, right? And 655 over 5 is going to be 131. Okay? So we see now that the trimmed mean is exactly the same as the median for this set. Only happened to work out that way. But it does lead us to see that the trimmed mean is probably a better or a more accurate measure, right? So then we're going to do 2010 to 2011. The trimmed mean is going to be 99 plus 98 plus 94 plus 91 plus 86 over 5. Okay. 99 plus 98 plus 94 plus 91 plus 86. It's going to be 468 divided by 5. So 468 divided by 5 is going to be 93.6, or about 94. So now for this set, we see that the trimmed mean and the actual mean are basically identical, right? So that means that there probably weren't any outliers. Does removing the highest and lowest values affect the mode and the median? Why? Well, obviously it affects it. It affects it because there's fewer numbers to deal with. But as we see from the 2010 to 2011 season, it didn't affect it really. It affected it very minorly, hardly at all, right? And that's because we could say the 2010 to 2011 season really didn't have any outliers first, right? There was no outliers here. But in the 1985 to 1986 season, it was affected quite a great deal, right? And that's because there were outliers over here. Should the outlier be removed? Why or why not? No, no, it shouldn't be, because this is a sport. This is a sport, and the person who got the most points should be lauded and remembered, not removed because they're a statistical outlier. If this was like, I don't know, just weights, lengths of like codfish or something like that, yeah, you take the one or two big ones out because you want a representation of the average, right? But here we're not even looking for the average. Now, where are we? We're already dealing with the 7 top point scorers in the entire season, so we're already looking at the top, right? So if we were to look at the top and then be like, oh, we're going to cut out the top 1 and the top 7 because reasons, it wouldn't make any sense. Right? So in context here, no, we would definitely not remove the outlier because we're already looking at outliers. We're already looking at the 7 top scorers for the entire season. So cutting out the top scorer because he's like super high point scoring doesn't make any sense whatsoever. Okay, so Esther, then I hope that was useful for you. That's going to be a little bit on outliers and central tendency and the trimmed mean. So I hope that has been useful. Yeah, because that is a topic that you do have to get onto, and it is definitely on your next review sheet. I have plenty more to talk about on that one, if you need more work on that in the future. Right? I just thought that that one might be a good one to sort of get ahead on. So now I'm going to go ahead and do the distributive property questions. I haven't heard back from Brittany yet. Oh, there's a nice picture again. Haven't heard back from Brittany yet, but I will assume that she will watch this at some point. So I'm going to go ahead and do some of these distributive property questions. So let's zoom in. And this is not from any of the activities that I give. This is just from one that I went and found online, right? So these ones aren't the exact ones in your book, but these are still a distributive property, so it will still be the same topic. So this is now math 2020, and this is distributive property. Okay. Now, let's go down through a few of these ones. So for question 1 then, distributive property here, well, there's not really much that we do with the distributive property in this first one, right? Because the distributive property kind of means that, well, we can factor stuff out, right? But to get to a point where we can factor things out with distributive property, we have to put all the like things together. So here we have x plus 3 minus 5x plus 7 plus 4y, right? So first what we're going to do is we're going to combine them all together. Now, this part is not the distributive property part, but it's something that we had to do first, right? So I'm going to go put these together. We're going to have an x minus 5x is going to be a minus 4x. We're going to still have our positive 4y, and then we're going to have a plus 10, because those two adding together there. Now, what's the distributive property part? Well, all distributive property means is that we can factor out parts of equations. That's all it is. And the reason it's called distributive is because it shows that this factor is distributed across all the different terms in that question, right? Or in that equation or expression or whatever, right? So here now, there's a negative 4 here, a positive 4 here, and a positive 10 here. So what's the greatest common factor that we can get out of those three? The greatest common factor is going to be 2. So I can factor a 2 out and call this negative 2x plus 2y plus 5. And that's all we can do, right? The distributive part is that this one, if we wanted to, could be multiplied by here, here, and here, and it would get us back to this setup here. But this is why it's called distributive. It's because this one is sort of distributed across all of those, right? So if you do number 2 is sort of going in the other direction. But we're just, in these questions, we're just showing sort of how the distributive property can apply in all these situations, right? So this one here is negative 4 outside of 3a minus 5b minus 7. So now we're just going to go ahead and multiply this negative 4 by everything that's inside there. It's going to be a negative 12a plus a 20b plus a 28. That's it. That's all you got to do. All right? That's all you can do, rather, because, you know, when we're talking about distributive, that's all that we can distribute across all these ones. Okay, this next one, question 3, this looks a bit harder, but it's really just all the same kind of stuff, right? We've got 9ab plus 3b squared minus 7b squared plus 8ab minus 12. And we have to use the distributive property to sort of simplify these guys. So what are we going to do? First up, we're going to combine all our like terms. So we've got 9ab's here, 8ab's here. That's going to be 17ab. Here we've got plus 3b squared and a minus 7b squared. So this is going to be a minus 4b b squared. And we just have a minus 12 over here, so that guy's going to be left alone. Now, one reason why we're given this question on this activity is sort of to show some of the downsides, I guess, of the distributive property. Because here, there's nothing at all that's in common in all these three terms. Because 17, well, 17 is a prime number. Its only factors are itself and 1. 4, its factors are 4 and 2 and 1. 12, 6, 4, 3, 2, and 1. So there's nothing that's in common between all of these for the constants. And then for the variables, well, there's an a and a b here. There's two b's here, and there's none there. So there's no variables that are in common in all three terms either. Well, what can we do? What can we do for distributive property? Well, the only thing we could do is factor out something from, say, two of these. And there's two different ways that we could go about this one, but we can't really do both. We could do either of these. We could either say, well, I'm going to call this 17a minus 4b with a b outside minus 12, right? So we could call it this, and this shows that we factored this b out of this term and that term. Or we could have it be 17ab minus 4 outside of b squared plus 3. And in this one, we factored a minus 4 out of these two. We could do either that or that, but there's no reason to do both. We're just going to do one or the other. And then for question 4, just to carry on, show you one more example here quickly. Question 4 with the distributive property is 9 outside of 4x squared minus 3. And all we have to do to show off the distributive property here is to show that this can multiply by those two. That's it. That's all you can do. So here now, this is going to be 36x squared minus 27. And that's all. That's all you would do there. Here we wouldn't really be simplifying it. We'd kind of be complicating it, sort of the opposite of simplifying. But that's all that you're going to be asked to do in these distributive property questions. It might seem a little bit confusing at first because it's like, is that really all I had to do? Am I just kind of like sometimes simplifying, sometimes expanding? But yes, that is exactly what you're going to be doing in these questions. Sometimes simplifying, sometimes expanding. Okay, I hope that was a reasonable amount on that topic as well. All right, great. So that was everything that I wanted to get to today. Thanks for hanging out with me, Twitch chat, for being here. Yeah, I'm doing this stuff every day. Every day. We're going to be doing it at 1 p.m. going forward, 1 instead of noon. We're going to start. Still going to go up to, around 2 hours or so, whatever gets me the stuff done that I need to get to the same day, along with all my rambling about, the lunch that I had, etc. Oh, and showing the lovely pictures of puppy dogs, of course. Of course, we got to do a bit of that too, obviously. Yeah, that's the good stuff. Okay, but yeah, thanks for being here. If you're watching this in the future, I hope this also helps you. Whoever is watching it, that I've linked you to probably, or maybe that you found it randomly. A man can dream. Okay, if it's helping you, please just drop me an email letting me know that you're appreciating the service. I'm glad for the opportunity to be here doing it. And yeah, I hope social distancing is going well for you. And carry on doing your math. Keep busy. Get your credits in. It'll be like it never happened, right? You'll come out of this with with loads of courses done and just be raring to go. Never really stopped. Okay. Thanks for hanging out, and hope to see you again tomorrow.